Alright, this is number 5 on the blue worksheet. So with the XY table for this one, we have a football that's punted with an initial velocity of 27.4 meters per second from a height of 1.25 meters with an angle of 33 degrees. So we're trying to figure out what the maximum height the punt will reach, how long will it take, how far away will the ball land from the original position, and how long is it in the air. So filling all of this out, we need to pay attention to the fact that this is going to be a height to ground with an angle due to the fact that we start from a height and we are definitely going to finish on the ground based on, personal experience with what happens when you punt football. It doesn't say that anyone is catching it specifically, so that's the situation that we're working with. So X table on the side, it all has the same things. There's never a change. So we're going to have our delta X, our Vx, and our Tx, and then our Y side has all those other variables. And then we have our totals. So we're going to have our overall initial velocity, our angle, and then our overall final velocity. So as a diagram, this is basically what we have going on. We've got our person kicking. It's beautifully drawn at an angle. It's at a height above the ground, so your projectile is going to go up, reach a maximum height, and then fall back down at that point. So with the information that we are given, there are 3 things that we know. We know the starting height, which is the delta y cliff of 1.25. We know the initial of 27.4 and the angle of 33. So given the fact that we know our overall initial and our angle, we should find our components, which would be VOX and VOY. So doing the process that we've been doing, we'll take our overall V initial, multiply it by the cosine of the angle, and that'll get us our X. And then we'll do the same thing in order to get our Y's. We're just going to flip the trig function and use sine instead. So we are going through and we're plugging all of that information in. So we end up with a VOX of 22.98, pretty close to 23, and then our VOY, which is relatively close to 15. So since our angle is 33 degrees, that means it's closer to the horizontal, so it makes sense that our X is larger than our Y. So once we have that information, the next thing to do is to try and figure out either how long it takes to reach its maximum height or how far up that maximum height is. We have options for how we go about doing that. We could do a couple different things with the fact that we know our initial velocity in the y direction and we know the fact that our peak velocity is 0. We could use the v final squared equals v initial squared equation. We could also use the delta y cliff to peak equation using 1/2 gt squared, but in order to do that we would have to find time first. So using that option, just because it's the more lengthy one, I'll show you what to do. We end up with 0 equals 14.92 plus negative 9.81 times the time up. Solve for that, and we end up getting our time up value. And that's the time it's going to take to reach the height from the foot, so where it's released from the foot up to its highest point. That would also be the time from the highest point to fall back down to foot level. So it's going to be up for 1.52 seconds. So we can take that number and plug it into our delta y cliff to peak equation. So we end up with 1/2 gt squared. So plugging everything in, we get that the delta y CP, which is cliff to peak, which would be the height above the kick point, it's going to be a value of 11.33 meters. So when we plug it in this way, we get a negative value because technically what that's showing us is the peak to the cliff because we started at the peak, which is why we were able to cancel out that initial 0. So based on the symmetry, we can just make it a positive value. That equation that we use is indicating that we're going down, but we want it to go up. So then our delta y peak to ground, which would be our third step, is just the sum of our starting height, which is delta y cliff, plus our delta y cliff to peak. So that's going to be our initial value of 1.25 added to the positive version of 11.33, and that'll be our peak to ground. So that calculation is going to get us our highest point above the ground, which would be the maximum height. So putting those together, you get 12.58 meters. So from the ground, we will have a point that is 12.58 meters in the air, and that's the answer to part A. Now part B says how long will it take to do so, which we already found that answer by finding time up, so that part's already done. Realistically, if you wanted to find delta y and then find the time, you would have to change the order of your equations, but you could do it either way. Alright, the next part we're trying to figure out how far away it's going to land and how long it's in the air. So we're actually going to work with part D a little bit first. So in order to figure out how long it's in the air, we need to figure out how long it's falling. We already have taken care of how long it's rising, So using delta y peak to ground of 12.58, we'll take that value and solve for the time down, and that's going to give us how much time it took to fall to the ground from that height of 12.58 meters. So by doing the math for that, we are going to get that the time down ends up being 1.60 seconds. So we are going to be falling for that amount. Now we were rising for a certain amount and then falling, so the total time that we spend in the air is the sum of both of those times. So time up plus time down, and again that's equal to time x. So that's our 1.52 plus our 1.60, which makes sense because a height of 1.25 meters to start is not very extensive. So the fact that we're going to only fall a little bit longer than we rose makes sense. So our total time, which is our time x, ends up being 3.12 seconds. Again, that's part D. And then part C, how far away will the ball land? That is our delta x, and we only have one delta x equation. Delta x is velocity in the x direction multiplied by the time in the x direction. So we end up plugging in our vx, which is 22.98, our tx that we just found of 3.12. When we complete that multiplication, we'll get that the range, which is how far away it lands, which is our delta x, is going to be 71.7 meters. So our projectile will land that far away. And that's answer for C.